Hello everyone, welcome to Mifratech. Today in this section we will explain solar tracking system code explanation. So in this solar tracking system mainly we used LDR sensor to track the sun, and according to we will rotate the track the sun using different DC motors, so that whatever the project we have explained, the particular logic or program required for this project I am going to explain you now. So in order to do that, previously you have to install Arduino IDE in your particular system or laptop. So there are two ways to open the programming file what will provide you. So mainly we are going to provide you a folder that will contain the solar tracking system Arduino programming file, so that I will show you. So now you go to file manager. So in the file manager, as you can see, it mainly provides for a folder which is named solar tracking system. So just have to open this, so wherever have you downloaded in your particular system or laptop, just open this folder. So as you can see, when you open this folder, inside there is a Arduino file present, solar tracking system. So this is the Arduino file which contains the programming part of this project. So this will be in .ini extension. So in order to run this program in your Arduino IDE, just you have to double click on this programming file. So whenever you double click on this one, the program will open in Arduino IDE. So that I will show you now. So as you can see here, now the Arduino, the solar tracking system program has opened in Arduino IDE when I double click on that particular program. So this is the one way of opening or running this program. There is another way that also I will show you. For that you have to close this one. So after closing this one, go to your home page of this your system or laptop. There you type in the search bar Arduino. So whenever you type this Arduino, so after typing Arduino in the search bar, as you can see, Arduino has been coming here. So you have to previously install in order to do this programming. So just click on this Arduino app. So whenever you click on this, the home page will open, as you can see here. So there are different options available here: file, edit, sketch, tools. So in order to open already present, like we have Arduino file which we have provided, in order to open that, just click on file. So after that there is a new, in order to open the new sketch or open, as you can see here. So just click on this open. So this will take you to this window. Here you have to go to that particular folder in your file manager where that solar tracking Arduino programming file is present. So as you can see, I come to the solar tracking folder and click on this solar tracking folder. So as you can see, solar tracking system, this is the Arduino file is coming here. Just click on this and open. So whenever you open this, so the programming file will open here. So that I will show you now. When you open that one, so as you can see, it has opened in the Arduino way, like Arduino IDE. So this is the another way of opening this Arduino file in your system or PC. So after that, I will explain the exact programming required for this solar tracking system. So as you can see here, mainly we are using two LDR sensor here. Those things we have to define earlier itself. So int LDR sensor 1 is equal to 3. What this line will do means, I have defined created an integer variable here, that is LDR sensor 1. So that in LDR sensor I connect to pin number 2 in the Arduino Nano microcontroller, whatever we used. So the digital pin number 2. So that I am assigning to another integer variable int LDR underscore sensor 1. Similarly, another LDR sensor I connect to pin number 3 of Arduino Nano. So that I am defining int LDR underscore sensor 2. So after defining LDR sensor 1 and 2, we have to define, mainly we are using two DC motors here for the in order to rotate that solar panel towards the sun. So here two motors, each motor has two input pins, so those I am returning here. So int motor 1 underscore forward motion, so that I am connected to pin number 4. Similarly for the reverse motion, int motor underscore 1 reverse, integer variable created, that I have connected to pin number 5. So two pins of one motor I connect to pin number 4 and 5. Similarly int motor 2 underscore motor 2 forward pin I have connected to pin number 6, that I can we are storing in this variable. Similarly int motor 2 underscore reverse, so is equal to RV7, pin number 7 I connected another pin. So these are the pins I have connected two motors, and that I have storing in different variables like motor 1 forward and motor 1 reverse. Similarly motor 2 forward and motor 2 reverse. So this is the initialization we have to do earlier. So after that in any Arduino programming there will be two parts, void setup and void loop. Inside the void setup we have to write the baud rate required, and pin mode we have to define, like sensors we what is the, like whatever the components we are using in the particular project, whether we are using it as a input device or output device, that we have to write it in the void setup. One more is void loop. Inside the void loop we have to write exact main programming logic for that particular project. So first we will do the setup now. So inside the void setup, the first line serial dot begin 9600. So this serial baud rate we have to set. Usually we will set 9600 baud rate. So after setting the baud rate, we will define the pin mode. So pin mode of LDR underscore sensor 1. So usually any sensor will use it as input. So I am defining LDR underscore sensor 1 as input. Similarly, pin mode of LDR underscore sensor 2 as input. So both LDR sensor we are using as a input here. So after that, all the DC motors or LEDs whatever will use, buzzer, those things will be output devices. So motor should be defined as a pin mode output. So pin mode of motor 1 underscore forward output. Similarly, motor underscore reverse output. So we have to define for motor 1 and motor 2 also similar way. Pin mode of motor 2 underscore forward output. Similarly, pin mode of motor 2 underscore RV come output. So after defining all the pin modes, here initially I am making all the motor 1 and motor 2 for both forward and reverse motion as low, because initially none of the motors should turn on. So I am making initially low them. So as these are the output devices, we can do digital write. So digital write of motor underscore forward I am making low. Similarly, motor 1 reverse, motor 2 forward and motor 2 reverse, I am making all of them as low initially. So this is the required setup for the initial stage. So now in the void loop we will write the exact logic of this solar tracking system. So inside the void loop of I am writing here, I am creating one more integer variable int LDR1. So as LDR sensor connected to digital pin, I am writing here in order to read the data, digital read of LDR underscore sensor 1. So whatever the sensor LDR sensor 1 that is collecting the data, that I am reading using digital read, I am storing in another variable the LDR1. So whatever the LDR1, I am now checking the status. So if the LDR1 is equal to 0 means whenever the LDR sensor becomes 0 means the motor has the LDR sensor has detected any sunlight. So whenever any sunlight is detected, at that direction the DC motor should move the solar panel to that direction in order to do the solar tracking. So if LDR is equal to 0 means I am making digital write of motor 1 reverse direction, and because I have connected LDR in that direction, so I am moving that in the reverse direction. So both motor 1 and motor 2 reverse direction I am making high. As you can see, digital rate of motor 1 underscore RV high. Similarly, digital rate of motor 2 underscore RV high. So after that I am giving delay of 700 millisecond. So this will move that solar panel towards the sun wherever the LDR sensor has detected, which LDR sensor is detected, that is LDR sensor 1. So that motor will move the solar panel to that direction. After that we should make, after moving to that direction it should turn off. So the motor should turn off, so it should be in that direction. So for that I am making digital write of motor 1 underscore RV low, again digital write of motor 2 underscore RV low. After that I am in the serial printer, I am making LDR2, I am printing it. Then a delay of 10,000 millisecond delay I am giving. After that again, after waiting for 10 seconds, I am making again a digital write of motor 1 forward high, again digital motor 2 also forward high. What these two lines will do is, it will again take the solar, after tracking the solar LDR sensing, it is going to that direction and it will come back to its original position after 10 seconds. So for that I am writing digital write of motor 2 forward means both it will, when it is going in reverse direction means it will be in another direction. Then come to its normal state and we have to make the forward forward pin of this motor, both the motors should make a high. So I am making motor 1 underscore forward high, motor 2 underscore forward high. So now the solar panel has come to normal position. So again I am giving delay of 800 millisecond. Again we should turn off the motor. So I am making motor 1 underscore forward low, motor 2 underscore forward low. Both the motors I am making low. So this is the required code, like logic, in order to do the solar tracking whenever an LDR sensor detected the sun. So it should go to that particular LDR sensor direction and it should track the sun, and again it should come back to its original position. Else if the LDR sensor is not detected the sun means none of the motors should turn on, means it should be in normal condition. So I am making digital write of motor 1, 2, motor 1 and 2 both forward and reverse direction I am making low. As you can see, digital write of motor 1 underscore FW, that is forward low. Similarly motor 2 forward low, motor 1 reverse low, and motor 2 reverse low. So this will do that. Next we will check for another LDR sensor. So So this will move in order to move the like solar panel in another direction. So in int LDR, for that I have created one more variable. Int LDR2 is equal to digital read of LDR sensor 2. Whatever the value read by the another LDR sensor, that I am checking. If that LDR sensor value is equal to 0, if of LDR2 is equal to 0 means it has detected the sun. So if the LDR sensor, second LDR sensor has detected the sun means you have to move the solar panel in that direction by moving the DC motors. So we have to write the same logic as we did for the first LDR sensor. So I am writing digital write of both motor 1 and motor 2 forward direction making high. So this will move the solar panel in that direction. Again 700 millisecond delay. Similarly motor, after that you should stop the motor. So motor underscore forward I am making low. Again I am printing in the serial and LDR1. So 10-second delay. After 10-second delay, so I am that solar panel will come back to its normal position. For that I am writing again digital write of motor 1 underscore reverse high, reverse 2. So as you can see in the program, for the LDR sensor 1 I written reverse first, next forward now to come back to normal position. But for LDR sensor I have connected in the project, I have connected in another direction. So in order to go back to that direction, initially I am making forward, both forward of motor 1 and motor 2 forward pins I am making high. So that will move to that LDR sensor 2 direction panel. And in order to come back to original position, we have to make reverse, both reverse pin of motor 1 and 2 we have to make high. So I am making here digital motor of RV high low. So after that, after 800 millisecond delay, I am making all the motors to normal, so it will be normal position. If LDR sensor 2 also not detected means, not detected the sun means all the motors should be turned off condition. So digital rate of motor 1 forward, motor 2 forward, motor 1 reverse and motor 2 reverse I am making low. So this is the required program for the solar tracking system in order to efficiently track the sun. So as I told, whichever the LDR sensor has detected the sun, at that direction the motor should rotate the solar panel in order to track the sun. So similarly it will come back to its normal position. Whenever another sensor detected, at that direction it will move. So whichever the LDR sensor detects the sun, at that direction only the solar panel will move. In this way the solar tracking system will work. So now we'll compile the program and upload it to Arduino Nano microcontroller. So in order to do the compilation, we have to first select the Arduino Nano microcontroller whichever we are using. For that, what we should do means we should click on tools here. So that procedure I will show you now. So now you click on tools. So whenever you click on tools, there is a, as you can see, board. So I have already choose the Arduino Nano microcontroller board. So we are using Arduino Nano here. If it is not selected means you click on board. There are different Arduino boards available here. Click on Arduino Nano. So it is selected now. So after selecting the node, so in order to do the compilation of the code, you need not to connect the Arduino Nano to your particular system or laptop. So you can do the compilation in the system itself. So just after selecting that, so as you can see here, I have not connected the Arduino Nano here, so only port is not showing. Now we are now to do the compilation. Below the file there is a right mark, it is available. It will do the verify, that is will do the compilation. So I click on this. So as you can see, compiling the sketch. So it will check the syntax of the program, or if any error is there means it will show here. So now done compile. So now the compilation has been done. So there is no errors in my program. If any error is there means it will be displayed here. So there is no error, so compilation has been done. Once the compilation has been done, you can upload program to your particular microcontroller. So for that, again you go to tools. After going tools, as you can see, and I have not connected Arduino Nano yet. So now I will connect my Arduino Nano microcontroller to this system. So after connecting that, so as you can see, whenever you connect Arduino Nano or mini microcontroller, port will display. As you can see, port have highlighted. So now you will click on this port, and as you can see, serial ports COM3. My Arduino Nano is connected to COM3. So this is need not to be COM3, it can be COM1, 2 or anything. So whatever it show after connecting your microcontroller, just click on this COM3. So after clicking on this, you can upload the code. In order to upload the code, after this compilation symbol right mark, there is another symbol, as you can see, right to arrow mark. So that when you click on this, upload will come, as you can see. So you have to just click on this upload. So this will be, the program will be uploaded to your Arduino Nano microcontroller, and the project will work like how I told. Whenever whichever the LDR sensor has detected the sun, at that direction the solar track, the DC motors will rotate the solar panel in order to track the sun. In this way, the solar tracking project will work. So thank you for watching the video. Thank you.